In this segment, we will show the components involved with heating the oven cavity and how they work together. The component list includes the R1 call for heat relay that receives the call for heat and triggers the ignition module, the ignition module that controls the heating process, the induced draft blower assembly and capacitor that creates a negative draft through the heat exchanger, the pressure switch which verifies the blower is working, the gas valve, and the burner assembly, which includes the igniter and flame sensor. To take a closer look at the burner assembly, we'll remove the box and turn it over. With a better view of the burner, notice the flame sensor and igniter. Here we see the ignition module. Next is the induced draft blower assembly with capacitor. And finally, the gas valve. We will simulate the inside of the gas valve to later illustrate its functions. We see the incoming supply gas, the valve solenoid, and the representation of the built-in gas regulator. When the unit is turned on without a call for heat, 24 volts AC is sent to the module that triggers a 30-second pre-purge. Here we see the ground from the unit, ground to the valve, 120 volt AC from the unit to L1, and neutral to the blower motor. Then we see 24 volts AC arrive at the 24 volt AC terminal, which triggers the IND or induced draft output to the blower. The motor is fed for 30 seconds to pre-purge the heat exchanger. Next, we will look at a call for heat triggering a trial for ignition. A call for heat is when 24 volts AC arrives at terminal TH and at the pressure switch. The module then performs a self-check to verify there is not flame rectification or pressure switch return before there's a call for blower or a call for flame. Then the module sends 120 volts AC from the terminal IND to the blower to begin a 4-second pre-purge. The blower closes the pressure switch, which feeds 24 volts AC back to the PSW terminal to prove the motor is working. Once the 4-second ends and the switch is closed, the module then sends 24 volt AC to the gas valve and high voltage spark to the igniter. The gas reaches the spark and the burners ignite. The flame crosses over to the flame sensor and a microamp signal is generated to rectify or prove the flame is properly lit. The minimum microamp current needed for this module is 0.7. If 0.7 microamps or greater is achieved in the 4-second trial for ignition, the sequence is satisfied and the burner remains lit until the call for heat ends. Next, we'll observe a call for heat ending. When the set temperature is reached, the call for heat is removed from terminal TH, and the V1 output to the valve and the IND output to the blower are stopped. The gas valve closes and the blower stops, which also opens the pressure switch and extinguishes the flame. Here we'll simulate a call for heat triggering an unsuccessful trial for ignition. Here the same sequence occurs, but this time the crossover will be unsuccessful, causing absent or insufficient rectification. Since the module cannot ensure the flame properly lit, it will end the trowel and perform a 30-second inner purge before trying again. Here we see the 30-second inner purge. The module runs the induced draft blower motor to purge any unlit gas from the heat exchanger before allowing another trowel. The module tries again, and this time the spark wire is simulated as damaged, causing absent rectification. Since the module still cannot ensure the flame properly lit, it will again end the trowel and perform a 30-second inner purge before trying again. For the second time, the module runs the induced draft blower motor in the interpurge period to purge any unlit gas from the heat exchanger. Here we will see the third and final attempt. It also fails, causing the ignition lockout. The module tries for the third time, and this time will simulate a failed gas valve, causing absent rectification. Since the module still cannot ensure the flame properly lit, it will end the trowel and lock out on ignition failure. Ignition failure is indicated by the LED flashing 3 times, then pausing and then repeating. The causes of an ignition failure can be the flame sense wire, the flame sensor, burner flame issues, spark or igniter issues, the spark wire itself, the gas supply, the gas solenoid, the regulated gas pressure, the V1 signal to the gas valve, the grounding of the ignition module or of the burner, or possible burner disrupting airflow problems. To test the microamp flame current from the flame sensor, use the pins labeled FC- and FC+ when the flame is contacting the flame sensor. Next, we'll look at a flame with no call for heat error. Here, when the call for heat is satisfied, the gas valve fails and does not completely close. This leaves a flame at the burner that the flame sensor informs the module of. Since the V1 output is not enabled, it causes a flame with no call for heat lockout. The flame with no call for heat lockout is identified by 2 flashes of the LED that repeat. Here we will observe the causes of an airflow fault. In this instance, the PSW output is lost, while the module has an output for IND active, which causes the airflow fault. The airflow fault is signified by an LED that flashes once and repeats. Alternatively, if the pressure switch is stuck closed when a call for heat arrives, the module recognizes this during the self-check sequence and also triggers an airflow fault. Let's look at how those errors reset themselves. We'll start with the airflow fault. When the pressure switch signal is lost, which triggers the airflow fault, it is monitored, and if it returns, the module resets and resumes normal operation after a 30-second pre-purge period. Here we see the pre-purge period after the PSW signal is restored and the trial for ignition to return to normal operation. Now we will examine how the module recovers from the flame with no call for heat error. If the valve properly closes after a period of time, the burner extinguishes and the flame rectification is lost. The fault is then reset and the module returns to normal operations. The ignition lockout resets by different circumstances. We will now review those. If the call for heat to TH is removed for 5 seconds or more and returns, that is the first way the module will reset from an ignition lockout. Or, if the call for heat is not removed, after 15 minutes the module will reset and resume with a pre-purge and trial for ignition.
I'm trying to help you out, ma'am. You want my help, yes or no? Okay, thank you. So, press and hold the program key to decode.
The final error that can occur is the control fault. It occurs if the module programming cannot run properly. To test for a cause, if the control fault error is present, remove the IND output from the module and cycle the heat cutoff switch for 5 seconds. When the switch is turned back on, if the solid red LED returns, the module is faulty. If, after the proper delay, the airflow fault appears, the module is not the cause of the control fault, and we should proceed to the next test. For the control fault's second test, remove the V1 output from the module and cycle off the heat cutoff switch for 5 seconds. When the switch is turned back on, if the solid red LED returns, the induced draft blower winding should be tested with an ohm meter. But if after 3 trials the ignition fault appears, the induced draft blower assembly is not the cause of the control fault, and we should proceed to the next test. For the control fault's third test, replace the V1 output to the module and cycle off the heat cutoff switch for 5 seconds. When the switch is turned back on, if the solid red LED returns, the gas valve solenoid should be tested with an ohm meter. But if, after the proper delay, the unit lights properly, the components are working properly, and this control fault is intermittent. For intermittent control faults, begin by inspecting all wiring for loose or poorly crimped connections, as well as damaged wiring. Then inspect to ensure the combustion blower motor is not overheating, and that the control compartment cooling fan is working properly and is not obstructed.